Hello, welcome back to Mr. Kendrick's online math class. This is going to be lesson 6.4 and we are going to be learning about the percent of change. Go ahead and turn to the next blank page in your math notebook and write this lesson title at the top. And a reminder, as you're watching this video, you can stop and re-watch this video at any time and make sure you're going at your own pace to get the most out of this video. Alright, percent of change. What is the percent of change? Percent of change is just the percent a quantity changes from the original amount. Okay, so we have two different types of percent of change. When the original amount increases, it's called the percent of increase. And when the original amount decreases, it's called the percent of decrease. Okay, so if your original amount increases, it's percent of increase. If your original amount decreases, percent of decrease. Go ahead and pause the video here. Make sure you write this information down in your notes. Alright, so this video will be going through examples, working to find how different quantities are changing, if they're increasing or decreasing. This next slide, I would like you just to write down this information. Our equation that we're going to use to find the percent of change is going to be the amount of change divided by the original amount. Okay, so as a reminder, we have this fraction bar right here, and that tells us to divide. Okay, so we're going to be dividing. We're going to be dividing the amount a quantity is changing by its original amount. Okay, and the way we're going to be doing this is right here. This is very important here. We're going to be subtracting the small number from the bigger number, and then we're going to be dividing by the original number. Okay, so our original number is going to be very important because that's going to be our divisor. That's what we're going to be dividing by. And then it's going to give us a decimal number, and our job is going to be to turn that into a percent. Okay, remember we can either turn it into a percent by multiplying by 100 or moving the decimal 2 places to the right. Okay, make sure you have this information down in your notes. Alright, this one I would just like you to watch as I work through this problem. So this one says, identify the percent of change as an increase or decrease, then find the percent of change. Okay, so our first task is to look at our numbers. We have 4 hours to 3 hours. Okay, so we're going to ask ourselves, is our original number getting bigger or is it getting smaller? In this case, it's going from 4 hours to 3 hours, so it's getting smaller, so it's going to be a decrease. Okay, so we're working with a percent of decrease, and then we're going to find out how much it's decreasing by figuring out the amount of change and dividing it by the original amount. Okay, so we're going to take the big number, which is the 4, and we're going to subtract 3, the small number, and then we're going to divide by the original. The original number is going to be the first number, so it's going to be 4. So now we have our equation or our fraction set up, 4 minus 3 divided by 4. So that is going to be, 4 minus 3 is going to be 1, and we're going to divide that by 4. Now you might be able to look at that and say that 1 divided by 4 is 0.25, but let's bring in our calculator just to make sure. 1 divided by 4 is 0.25, so this is equal to 0.25. Okay, now we need to turn it into a percent. So you can either just scoot your decimal over 2 places, or you can multiply by 100. So if we bring back our calculator here, and we have 0.25, we multiply by 100, we get a percentage of 25%. So this is going to be 25%. Okay, and then we got to ask or remind ourselves, did our original number get bigger or smaller? And so the answer to our question here would be that we had a 25% decrease. So the original number decreased by 25%. All right, now it's your turn. Go ahead and pause the video here. Try these 4 examples down and make sure you write them in your notes, and then come back and see how you did. So we're working to identify the percent of change as an increase or decrease, and then we're going to find that percent of change. And if we need to, we're going to round to the nearest tenth of a percent. All right, so the first one here, it says 160 pounds to 150 pounds. Okay, so first we need to identify increase or decrease. Our original number was 160, and now it's 150, so we have a decrease. So I'm going to write decrease here. We have a decrease. Okay, and then we're going to find out that percent of decrease by subtracting the big number, so that's 160, minus 150, and then we are going to divide by the original, which is 160. 160 minus 150 will be 10, and 160 as our denominator, and then if we divide that, we get 10 divided by 160, and that's a decimal of 0.0625, so we get 0.0625. And now you can slide your decimal over 2 places, 1, 2, and you get 6.25%. And then remember back, it is a decrease, so we have a 6.25% decrease for number 3. All right, number 4, we have $5 to $8. So again, we're looking for, is it an increase or decrease? We started with $5, and now we have $8, so it is going to be an increase. So increase. Okay, now we can set it up. The big number minus the small number, so that's going to be 8 minus 5 divided by our original, which was 5. So 8 minus 5 is going to be 3, and then our divisor is 5. Bring back our calculator. And 3 divided by 5 is equal to 0.6, so we get 0.6. Okay, now we can multiply that by 10 to get our percent. By 100, so times 100, and we get 60%. And it was an increase, so we have a 60% increase for number 4. All right, number 5, 12 cats to 32 cats. So from 12 to 36, so that is an increase. And then we will have the big number minus the small number. So the bigger number is 36 minus 12. And our original number was 12. So 36 minus 12. 36 minus 10 would be 26. Minus 2 would be 24. So we get 24 divided by 12. And 24 divided by 12 is 2. Alright, now 24 divided by 2 is a whole number, or 24 divided by 12 is a whole number of 2, so our decimal would be here. We can add our zeros. You can either scoot your decimal over or multiply by 100 and you will get 200%. So our answer here is that we have a 200% increase in the number of cats. All right, number 6, 14 cups to 12 cups. So from 14 to 12, that's going down, so decreasing. So we have a decrease, and we have 14 to 12. So 14 is the big number, minus 12, and 14 is our original number. 14 minus 12 is 2, and we're divided by 14. Bring back our calculator here. 2 divided by 14, and we get 0.14. 0.14. I'm going to round that decimal. 0.142. I'm going to round it to 0.143. So we get 0.143. And then we can multiply by 100 times 100. And we get 14.3%. Okay, so in number 6 we have a 14.3% decrease. Alright, so number 7, for our notes, we're going to be looking at percent of error, which is the percent of an estimated amount that differs from the actual amount. Okay, so and the way we're going to find that is we're going to figure out the amount of error, and then we're going to divide by the actual amount. Okay, and it's going to be the same thing that we were just doing. We're going to subtract the small number from the big number, and then we're going to divide by the actual amount that it's supposed to be. Okay, so go ahead and pause here. Make sure you get this in your notes, and then push play when you're ready to continue. Alright, for this one I'd just like you to watch as I work through. This question says, a company fills boxes of cereal with about 32 ounces of cereal. The acceptable percent of error in filling a box is 2.5%. If a box of cereal has 31.1 ounces of cereal, is that an acceptable weight? Okay, so we're trying to figure out the box of cereal is supposed to have 32 ounces in it, but in this case, this box has 31.1 ounces in it, and the acceptable percent of error for these boxes is 2.5%. Okay, so we're going to try to figure out if this is an acceptable weight. And we're going to do this by using this template here. We're going to figure out the amount of error, and then we're going to divide it by the actual amount. Okay, and we're going to subtract the smaller number from the bigger number, and then divide by the actual amount, so what it's supposed to be. Alright, so here we go. Amount of error. So the big number is 32, and the smaller number is 31.1. And then our actual amount of what it actually is supposed to be is 32. So we're going to divide by that. Okay, so if we bring our calculator here, and we say 32 minus 31.1, we have a decimal of 0.9, and we're going to divide that by 32. So we got 0.9 divided by 32, so our 0.9 is here, we're going to divide that by 32, and that's going to give us a decimal of 0.028125, and if we want to find that percent, we can just multiply it by 100 times 100, and that is a 2.81% error. Okay, so if this is going to be 2.8% error. So now we can go back to our question. The acceptable percent of error in filling a box is 2.5%. In this situation, our percent of error is 2.8%, so this would not be an acceptable weight. Okay, and this question a little bit of context. When a company is filling boxes of cereal, they only have a certain percentage of air, so that helps them not lose money if they're either filling a box with too much cereal or filling it with not enough. Then that will cause problems for the consumer, and they don't want to do that. All right, so let's try some examples here. Number 8, it says you estimate that a baby pig weighs 14 pounds. The actual weight of the baby pig is 16 pounds. Find the percent of air. Okay, so again, we're going to subtract from the smaller number from the bigger number, and then we're going to divide by the actual amount. Okay, so the big number is 16 pounds, and the guess was 14 pounds, smaller number. And then our actual weight is 16. So now if we subtract 16 minus 14 is 2 divided by 16. 2 divided by 16, and we get 0.125, and if we times that by 100 for our percent, we get a 12.5%, equals a 12.5% air. Alright, so that would be our percent of air there. If you estimated the weight at 18 pounds, what would be the percent of air? Okay, so now we're going to see what it would be if we had 18 pounds. So again, we're going to subtract the smaller number from the bigger number and then divide by the actual amount. So in this case, we would have 18 as the big number, so that would be 18 minus 16, and then the actual weight is 16. So if we divide, we get 18 minus 16, and that would be 2, divided by 16 again. And so that would be 12.5% as well. So you might think, why are they both the same percent of air? And in the first situation, we were 2 pounds too light, so it was a 12.5% too low of a guess. And then the second one, if we estimated at 18 pounds, that would be 2 pounds too heavy, so that would be a 12.5% air on the other side. Okay, so both of these, one was 2 pounds too light, the other one was 2 pounds too heavy, but it was the same percent of air.